Welcome to everyone. This is session 16 of the Ozone Technology course, and this session will be providing some information on the parameters of potable water and application in the ozone treatment. The common parameters in the treatment of potable water are particulate matter, dissolved solids, total organic content, total inorganic content, biological oxygen demand, chemical oxygen demand. As we all know that we obtain our drinking water from the river, reservoirs or dams, and as they are open systems, you can expect plenty of floating debris such as small leaves, twigs, and other insoluble matter such as mud, sand, solids, small stones, etc. Now, when we take the water from these natural sources, we have to use a pump, and the pump will drag out the water, and along with many of these particulate matter. It has to be taken through the sand filter so that all this floating debris can be filtered. TDS is generally known as total dissolved solids. Mostly these are soluble salts of sodium, calcium, and potassium, etc. Potassium is not generally involved because most of them are soluble, but sodium, calcium, magnesium, etc. can have insoluble salts sedimented or dissolved. Usually when they are dissolved, they pass through the sand filter. So if the sodium salt is very high, it will not be potable, particularly like seawater, where the salt content is too high, we are unable to drink that water. But in normal drinking water or reservoirs and rivers, the waters are generally pure from many sodium salts. These salts cannot be removed by filtration. The high TDS in many natural waters are generally due to calcium compounds. Most drinkable water, the TDS would be between 0, which is very pure water, and up to 400 to 500 ppm of TDS. The taste of 500 ppm TDS will be very flat, and it's called hard water, whereas water which has got TDS below 50 ppm are generally soft water. TDS is measured by its conductivity. Conductivity, as you know, is where electric current can be conducted through the water with the TDS. The conductivity of TDS is higher than 4 to 500 ppm, makes the water undrinkable because it becomes too salty or too, what you call, flat. TOC, or total organic content, are soluble organic matter leaf components, rotted matter or animals, organic additives from factory effluents discharged into the river, etc. The TOC is generally low in river waters and reservoirs. They form a colloidal solution which cannot be filtered but can be only removed by flocculation. Biological oxygen demand is that part of the TOC that can feed the bacteria. BOD is also generally low in fresh waters. They are only removed by flocculation through the addition of alum and either ferrous sulfate or polymers that will coagulate the colloidal solution and settle them as precipitates in the settling tank. Chemical oxygen demand is the amount of inorganic chemicals that are oxidizable, such as sulfides, nitrates, soluble iron, soluble manganese, etc. It is determined by oxidizing a known volume with a strong oxidizing agent and then titrating. The chemical treatment process will address all these factors before sanitizing the water that will be ready for consumption. This slide represents a diagram of a water treatment process generally used by small commercial or community water treatment. The reason is the fact that the water is generally not of very good quality and therefore would require coagulation and sedimentation and followed by filtration and before the chlorination. During the process of coagulation and sedimentation is quite a tedious process, and generally it will not be commercially viable for large community and very large council or state water treatment systems. As once the water that has been sedimentation has been completed, the water goes through the filter and goes straight into the reaction chamber where chlorination and chlorine or chlorine dioxide dosing takes place, and then it goes back to the storage tank. From the storage tank, it goes up to the water tower, which becomes a buffer that provides a pressure should there be any problem with the pump, and it goes to the distribution, or where a factory is concerned, goes directly to the inline of the factory. In distribution, they use ammonia and chlorine to maintain the chlorine levels in the distribution system, because when the water is stored, all the chlorination disappears, and therefore the water has to be rechlorinated so that any possible contamination in the distribution channels will be taken into consideration, so that the water that comes into these houses is clear and free of bacteria. The sediments and the filter sludge go straight to the sludge digesters, and where they either use it to bacteria to digest, biodigestion, and then use the water, or they might decide to remove it as sludge to a disposal area. This is another treatment where activate carbon is used besides alum and polymer, and then chlorination. Again, this also can be for small community areas. The water from the canal passes through the charcoal filter or activated carbon, and then it goes back into sedimentation tank where the sedimentation takes place, and the water overflows into the second chamber, from where the water is further filtered, and then fluoridation is added for the community, and treated water is treated, and then chlorine is further added before it goes to the house taps. This is added in the distribution system. This slide represents another form of treatment, also for small-scale commercial applications. The water that comes from raw water goes through the sand filter, and as it goes into the flocculation tank, alum and ferric chloride is added. Flocculation takes place in the flocculation tank, is settled, and the sludge, the sediments are taken through the sludge pump back to the sludge filter, and the water is recirculated into the tank. From this tank, the clear water is filled into the clear water tank, from which the water goes through the pump and into the distribution tank, and chlorination is pumped in the clear water tank, so that the water that comes out will be sanitized. In the case of a Coca-Cola Export Corporation, the water they use, particularly for manufacture of Coca-Cola beverage, must be free of chlorine, and therefore, in order to remove the chlorine, they pass it through a secondary charcoal filter and then get the chlorine-free water, which is used for the factory to manufacture the Coca-Cola. This process of treating water uses the UV as an initial disinfection. That is, the raw water is passed through the filter to go into the clarifier, and from the clarifier it goes to the sand filter and then goes straight to the UV treatment, where the water is sanitized, and then it goes through the ammonium chlorine is added, it goes to the contact tank, and they probably add sodium phosphate or phosphates to remove any hardness, and you will have a treated water, which is then directed after filtration through the potable water system. So the UV is the secondary. UV treatment is the primary sanitation, and for the sanitation of and maintaining the sanitation through the pipes, they will use ammonium and chlorine. In the summation, the common treatment procedures of industrial potable water treatment using chemicals are satisfactory for most purposes. However, if water is to be used for electroplating, kidney dialysis, medical and surgical applications, it must be completely free of organics, bacteria and all chemicals, and generally the normal treated water is unsuitable. So in order to obtain this quality of water, they use deionization or double distillation processes and antiseptics for surgery. But they have not been using ozonation much. I would like to mention some information with respect to the quality of water treated by chemicals. Generally the treatment is by chlorination. Chlorination is quite satisfactory and achieves quite a significant degree of sanitation, but not to the extent of sterilization. The difference between sanitation and sterilization is that in the case of sanitation, there might be small amounts of bacteria which are not harmful but will not have any harmful bacteria or pathogens. But in the case of sterilization, there will be no pathogens and no bacteria, and that sterilized water is completely free of bacteria and virus as well as our organic materials, etc. It is not sufficient to oxidize to remove the dissolved organics, because dissolved organics cannot be removed by normal chlorination process, and it's in order to remove the completely dissolved organics, you will have to use, for example, the flocculation system, but that also may not be complete because they will have other elements added to it. With respect to treated water by chemicals, as we all know that chlorine is good enough to kill almost 99.99% of all the bacteria present, but there will be some 0.001 ppm of bacteria, percentage of bacteria, which is resistant to chlorine, and that remains dormant until the chlorine toxin are depleted, and then they regrow and multiply, particularly in the presence of organics. For example, if you keep a bottled water for weeks and then open it, you will find the water stale and undrinkable. For complete sterilization, the chlorination must be at least 1 hour with a concentration of 10 ppm, and for viral removal, it must be at least 50 ppm. This concentration is too high, corrosive, and chloride contaminated, and possibly with the side reactions with organics to form toxic chloramines, and not practical with most applications, such as sewage treatment. Sewage treated water sanitized by chlorine may not have all the pathogens removed, and it will be unsuitable for secondary or recycle use unless used as brown water. We have come to the end of the session 16. Thank you very much for having the patience to listen to the presentation. The next session 17 will be application of ozone in potable water. If you are new to this session, please refer to sessions 1 and 2 of the course program and sessions 3 to 15, which gives information on all matters related to treatment of water. If you like this presentation, please click the like icon and subscribe icon, particularly if you want to be notified of the uploading of the next session. Thank you once again and have a good day.